Okay, this is assignment 1. This is the work that we did in class on, would have been Wednesday. Okay, so that would have been CIS-125, and that would have been 9/9/15, and this would be day 3 of the work. We had done a number of these things already. We had talked about the perimeter problem, assignment 1. It's a farm example. And in understanding the problem, we'd work out the IPO, the input, the process, and the output. And understanding the problem, you really need to know what they want out. And in this case, it was about a farmer is going to paint a box out in his field, and he wants software to determine how much paint he needs, how many gallons it'll take just to paint that perimeter, the distance around. And he knows as he paints, you can get 300 feet to 1 gallon. Okay, so he needs to know the perimeter, the distance all the way around, in order to figure out how much paint he needs. Okay, so we're going to input the length and the width. Okay, the length, if this is referred to as the length and the width, and you could determine that either way. So we're going to use these two variables. And later on you'll see we put those in a legend. To indicate what variables represent what. And so what these are going to be, they're really going to be places. If this is memory, they're going to be some location in memory. And then here's the processor. The process will have to calculate the perimeter and then use the perimeter to calculate the gallons. And the way we're doing is length plus width times 2, and our output would be gallons. And we have some test data. We're going to practice with 200 and 300. So we're only going to do it once, so going through that would be a sequence problem. So we start out with the flowchart. We have a start and a stop box. We draw arrows. You can see right here we have an arrow that connects this box to this box, so we know exactly where we're going. This box is the initialization. We're going to let feet per gallon equal 300 just in case that changes. Here we have an input box, and we're careful to make sure our lines touch with an arrow. An input box is 1 in, 1 out. Initialization box, 1 line in, 1 out. And the same thing with these process boxes. Only 1 line in, 1 line out. And so this is going to be just a sequence problem. One step after another, and then later on we'll talk about repeating it. So we input the length and the width, so those both go. So we have our 300 stored here from this line. Then we got an input and length and width. Then we calculate here. Very important. Calculations on the right, store it to the left. Calculations on the right, store it to the left. Always. You never reverse that around. And then down here we print the gallons, okay, which we calculated here, and we were able to do that because we got the perimeter from here. And in the computer, these instructions are going up into the processor is sending back the results, they go up into the processor sends back the results. Okay, so we'll review here, and what we did here is we took and wrote pseudocode. Okay, so here we have a flow chart, a picture representation of the program, and here we have pseudocode or false code. Okay, this isn't exactly computer code, but we write it in word form so we can look at it more like a list rather than a picture. And it has those same instructions. It's got, you know, here it's got the start, assign, this is initialization, input, calculation, print, stop. So we just one sequential program. Okay, so this here is the pseudocode. And the rest of that over here, that's all the flowchart. And you can see how it flows. And we typically write it down or down and to the right. The flow. Don't cross lines over. Make sure they're connected. Make sure you have arrows. And these boxes, one in, one out. These boxes are one in, the terminating box, and the starting box is always one out. This part today, here's the legend. We specifically explain what each variable is. Okay, so there's no confusion. Legends can be put into your code depending, if they're really self-explanatory, you might be able to omit that. In some cases they would say you always need it in your code, but somehow people need to know exactly what the variables represent. Okay, so later on we'll talk about putting in the code, especially when the programs get a little more complex. And then the last thing down here is our walkthrough, or desk check. You hear both terms used. This might be used a little more recently. So in step 1, the first step in the program, we initialized this variable to 300, and these variables were all 0 yet. Okay? And actually that's not a variable, that's our output. Nothing gets outputted until the last instruction. Then the second line, that's still 300, and then we inputted our test data. These are still blank. The third line, we calculated the perimeter. We took 300. We took the 300 and the 200, the length and the width. We added them times 2, and we get 1,000. Nothing in those. And then those variables are all the same. We have 1,000. We divided that by this amount, and we got our 3.3333. And then the last line, all those variables stayed the same, and we output it and printed it. So the last thing, and I'll have another video to talk about this, we'll actually write some code in Python to do this process, this algorithm, calculate how many gallons we need. Now, we'll talk about it also, since it's 3.333, we would really want to take that then eventually and output it as 4 gallons to make sure he has enough paint. That's it.